Hello, Applied Pre-Cal. We have made it through our relations and functions unit, and we're moving on to linear functions now. This is the second of 3 units that cover linear equations. We're going to look solely on functions at this point, and then in a few weeks, once we complete this, we'll look at systems as well. The topic that we're going to start with is something called the slope. Now, what you're familiar with, if I said the word slope, would be like the steepness of a line. And that's exactly what this is. When we draw our graphs, we either have a very steep line or we have something that's more of a shallow or less of a steep line. And that is defined by something called the slope. We have an equation to define that. So there's a few ways that we can state it. One of them, probably the most common one, is slope is equal to the rise over the run. So you take the rise, we'll define what that is in a bit. You divide that by the run and you get something called your slope. Another way that we can look at this is m is equal to delta y over delta x. Delta is just a triangle. It's a Greek letter that we use and it defines the change in something. So the change in your y variables divided by the change in your x variables. We're going to look at this through 3 different types of examples. So the first type of example we're going to look at is if I was to ask you to determine the slope of a line. All I need to do is give you the line on a graph and you should be able to tell me how steep that line is. Now, just by looking at it, it doesn't really look that steep. I mean, like if it was a ramp for us to walk up, or like a wheelchair ramp or something, I don't think this would be too intimidating. Whereas, if it was something that was like a mountain, that would be obviously more difficult. But numerically, what is the slope of this line? Well, what we can do to determine that is we can use our equations for rise over run. Now, rise, just like the word, defines how many blocks up or down we're moving, so how much we're rising up or how much we're rising down. And the word run defines how much we're moving left or right. So am I running in this direction? Am I running in this direction here? It's hard to do it with just a line, but remember every single line is just an infinite number of points joined together. So we can pick some easy points on this graph, and we'll use those points in our equation to solve for the slope. I'm going to select these 2 points. And it might be hard to see there, so I've written them down here as well. I'm just using the notation that we would have looked at in grade 9. If you don't remember, that's okay. Well, it's in practice. But I have a point at 2, 0. So on my x-axis, if I move 2 units over, I have a point there. And on my y-axis, if I move 1 point down at 0, 1, I have a point there as well. Why that's important? Well, now I can use my formula for slope. So here you have to understand what the phrase change in means, or delta means. You're taking 2 points, 2 values, and you're just subtracting them. When you subtract 2 values, that's how you calculate the change or the difference. So in this case, when I say change in y, I need 2 y values. Because I have 2 points, it means that I have 2 y values. So I've chosen 0 to be my first one. It doesn't matter which one you choose to be first, you get the same answer either way. So I've chosen 0 to be first, minus my second y value. My second y value is -1. So I have 0 minus -1. And I did the same math for my x values, 2 minus my other x value, which is 0. And when we calculate that, we end up getting a slope of 1/2, 1 over 2. Now, how can we confirm that? Well, remember, our slope means rise over run. So this formula is telling me that every single point moves up by 1 and over by 2. And let's take a look, see if that's true. If I start at -1 and I move up 1 unit, I should be on the x-axis at 0. And if I start at 0 on my x-axis and I'm moving 2 units over, I should end up at +2. And that's true. The opposite should also be true. So notice I haven't highlighted any points in this bottom left quadrant, but let's use the logic. My slope is moving downward, so I'm going to move down 1 unit from -1 to -2, and I'm going to move back 2 units from 0 to -2. And let's see if we have a point on our line. So -2 is here, -1 is here. Would you look at that? We do have a point on our line, -2, -2.